It's K8BYP in the Cram Shack with a great amount of radio stuff crammed in a small room. And the topic today is, for you amplifier fans, about amplifier fans. In the old days, they used mechanical blowers, huge, noisy, extremely noisy things. They would pressurize an entire cabinet and use that to create airflow up through the base of that tube and between the tube and the chimney. That's a poor design because it wastes pressure. What I'm doing here is using these modern, what we used to call muffin fans, I guess. These plastic fans with the extremely deep groove blades, and they can move a tremendous amount of air with 12 volts and low current. This fan was, I think, $35. A modern mechanical blower would probably run you $300. And you can probably change an old blower out and replace it with one or two of these for $50 if you understand how to set it up correctly. I had this all mocked up and found that these fans, well, all fans, but especially these, are very sensitive to placement. So I'm going to go over that here briefly. And in the second part, in 2 videos ago, I showed you using the digital manometer, how and where to use it to measure pressures, because again, airflow is not enough. It must be at a certain minimum pressure for the certain correct air density, because it takes the correct mass of air. Flow isn't enough and pressure isn't enough. It has to be at least certain figures on both. For this tube, it's about 15 CFM at half-inch water column, and half-inch water column implies pressure. First, a critical note on exactly how to install these tubes. I've seen ham amplifiers that had the tubes sitting up on the chassis deck, assuming that's the deck, and that is wrong and very bad. These tubes, that plate in there, gives off a tremendous amount of infrared energy. That plate's in a vacuum. It has no way to lose heat. Heat cannot transfer through a vacuum, so it emits by infrared radiation. The second thing is, especially at a couple kV of RF, there are tremendous electrical fields coming off that plate. And in these tubes, if you look in here, you'll see this solid metal disc with this serial number on it, and then this metal shield. And the only acceptable way to install that is assuming that this is up and down. We can't mount these sideways. The plate cap has to be vertical up or down, else the elements will get hot and sag inside and cause a short. But the chassis, the floor of the chassis, must coincide with that gap in between these two for shielding between the plate, which is the output, and these pins down here and the circuitry from the exciter and power supplies on the input. If that isn't done, there'll be a tremendous amount of feedback of energy from the plate to the input, and that can lead to oscillation. So this tube has to be installed with this ring, the top edge of this ring under the deck. The hole in it needs to be fairly close to this, and IMAX says that junction between the metal deck here and this ring has to be grounded by spring fingers or something like that to make it so that RF can't leak through that gap and get down in here. So if you have an amplifier that's not set up that way, you need to turn it off and change it. Now let's assume this tube is properly installed and the line of the deck is right here and the chimney's resting on the deck. And in the 4-1000s, actually this goes all the way down to here. But here comes the fan. I made this cardboard enclosure, courtesy of Little Debbie, to test the sensitivity of this fan to distance from that plate on the outlet. And I found that at spacing of about 1.5 inches or less, the static pressure began to drop. That's not good. At about 1 inch spacing, it wasn't too bad of a drop. That's the benefit of being able to use this fancy $300 digital tool. It'll indicate 0.01 inches of water column, and I can use it to test the sensitivity of this fan spacing. That wouldn't be so easy to do with a YouTube water manometer. So I determined about an inch spacing is about optimum. What I was surprised to find is that if this is vertical, there needs to be a clearance under this fan, between the fan and the bottom of whatever enclosure is under it. And I found that it needed about 3 inches spacing above, else the airflow started to drop off, and that was surprising. It can't be like this. And so that defines the minimum height of this overall assembly from here down to the floor of the enclosure underneath. Now, one of our viewers, going by the handle of Big Boy something 1, I think it was, says he has an amp with two 4-400s. That might right off be illegal. We're only allowed 15 dB gain. And these tubes, each of these tubes can have about 20 times. So regulations out of the way. What he said is that he put a fan near or supplying the base of each, which is fine, but also put one at the outlet. And that might be detrimental, because if we have some conduit that's passing airflow here, and we put one of those fans down here, and there's some restriction here, and that fan is making, let's see, that's making 10 CFM at, let's say that's making 10 CFM at an inch water column because of the pressure here. If we put the same fan up here, then this is +1 inch, and this is -1 inch. And what's the result of plus and -1? In the middle, we get 0. Now that's very simple. That's mechanical. That's not electrical. But what that implies is that there's no pressure in between. And now we're violating the requirement to have 10, or the desired condition of 10 CFM at an inch, and realize that this factor here is what more or less creates density. Air. And the air density means that there's more air molecules flowing in the space between the inside of that chimney and the outside of that glass to carry away heat. As that density approaches 0, it approaches a vacuum, and there can't be any heat transfer, so the tube will burn up. So he said he'd put a fan below each, and then one to, in my terms, probably evacuate the cabinet. And I get it. That's how I had this unit set up. But on second thought, that might not be good. On the outlet of the chimney, between the chimney and the tube, that's a large opening. When I removed this, there was a extremely small drop in pressure, implying that this opening is big enough to make almost no difference. So it should be a case where if this is opening up into an enclosure that's a huge manifold, in the case of 2 tubes, it'll be a manifold because it's combining the flows from both. And if there's a hole someplace or screening that has sufficient opening size, then there should be no need for a suction fan. There's a website in Germany. I don't recall the name. I'll post it in the video description. It's an excellent document on fans and airflows. And they say it's acceptable to put 2 fans in series, one pressurizing the inlet of the other. The pressures will add. It says it's not acceptable to put 2 in parallel because one will do something the other won't. There's a similar principle with semiconductors like diodes. We can't put them in parallel without going to a lot of trouble, because the one that turns on first will carry all the current. So If the static pressure is too low, it's possible to couple two of those fans together. You need to experiment with the spacing, because I doubt that it's acceptable just to fasten them directly together. They may need an inch spacing. So this is where we have to build it and test it. This airflow and heat transfer is so extremely complicated that it takes supercomputer modeling to actually calculate it. We don't do that in mechanics. We get close and we start testing. And the close aspect here is that we're using a pre-made chimney tube, all that stuff. But we got to assemble it and then verify it. And one of his comments, he mentioned driving the tube before it's warmed up and seeing high plate and screen currents, and I'm still trying to figure that one out. But that sounds very bad. By the way, in the background, the load resistor bank, the plate load for the microwave oven-based tube tester that I'm engineering and building, and it's become a pig of a project. This thing is extremely difficult because it's exceptionally dangerous, because it's intended to have operator contact with the tube very frequently. In an amplifier unit, we put the thing together and we don't ever open it up again unless we have to clean it or fix something or change a tube. So since this is designed for regular contact with points that could be deadly, I'm going to a tremendous amount of trouble to engineer this correctly. I don't recommend this project at home. It can get you dead. And now to make the UTube manometer, U, the letter U dash tube, not Y-O-U-T-U-B-E, to replace this $350 digital toy. We need clear polyethylene tubing. This is too large. Use about 1/8 of an inch. This will hold a lot of water. It'll be less sensitive than a smaller tube. But the principle is, we all know a cup of liquid with a straw. If we put suction with our mouth on top of the straw, liquid's drawn up inside the straw and up into our mouth. Why? Well, it's not just because of the suction, it's because of the atmospheric pressure down on the liquid. Same thing with the UTube manometer. Make a J-shaped arrangement with this polyethylene tubing and put water in it. So there's some, that's a little short there. But put water in it to make a U shape. And if suction is applied to here, atmospheric pressure here pushes down and displaces this column of water from here someplace up here along this inch scale. Use centimeters if you're in Europe, because you'll have metric water over there. Is water metric in Europe? Maybe one of our European viewers can tell us. Maybe that goes along with the sink draining reverse in Australia. But in proportion to the amount of pressure plus or minus here, that water level will rise. And it's literally called inches of water column because this simple U device has a mechanical scale placed beside it, like this mechanical machinist ruler. And we literally indicate the pressure by how high that column goes, and that's all there is to it. The huge 4kW amplifier I got from WB4CTW actually had a pressure port built in the cabinet for constantly monitoring pressure. So there would have been one of these UTube devices on the cabinet. It was gone when I got the amplifier. So to use this, especially in suction, if it's going to be used with pressure here, water displacement will be the opposite direction. And here it's going to push water out the other side of this and make a mess. So maybe raise this side of the U up a similar amount as would be displaced over here so the water can't be pushed out. But just connect some kind of fitting or device on this end of the hose. Here I've used a piece of brass tubing to fit down through drilled holes in that brown plate material. See the hole there? So that just makes a way to get down in without putting a nipple fitting on the cabinet. Just push it down through the hole so that end of that rubber tubing seals off the hole. So that's literally all there is to making it. Maybe mount this on a piece of board or a piece of plastic so it has some shape to it. But use that. No power in the amplifier, no high voltage. Start off with it cold. Don't get dead, because being dead is so limiting. But test this kind of assembly cold, and then realize that's not good enough, because it doesn't operate cold. And there's no specification for airflow and air density when it's cold, because the air isn't doing anything. It has to be verified when hot. But by the time you've worked this out cold and done cold testing, you'll be familiar with how to do it safely and not get the living you-know-what knocked out of you by that plate terminal. So arrange your pressure measuring locations away from points with high voltage. That should be obvious. But make sure you can't accidentally move a hand around and brush it against that plate terminal, because they might be throwing dirt over you next week. These tubes are very dangerous in operation. So careful. There's no such thing as dead viewers. As an intermediate step, a test, without turning high voltage on, just turn the filament on and let it heat up. In the measuring airflow video 2 videos ago, I showed that the top of that envelope reached 170 Fahrenheit just from the filament. And that's how I knew airflow was not sufficient. It shouldn't have gotten that hot. So that will heat the tube partially. Not nearly as much as if it's operating. And realize that that plate in there is only giving off a small amount of energy that's being intercepted by that glass envelope and chimney. That's the glass items are heated by infrared emission from the plate. But the glass is mostly transparent and very thin, so it's not a great deal of heat. So understand that the airflow that's intended to operate the tube should really cool that way down if it's just a filament, because it's not causing the glass to intercept much heat. And that in no way are these fans specified by IMAC or whomever enough to cool the 400 watts of radiation coming off that plate. That's infrared energy coming out and going into the cabinet, and dealing with that is an entire different complicated topic. That energy has to be taken out of the cabinet. If it isn't, in theory, it could all come back and heat the plate. So that's the overall picture here, with emphasis on it's got to be verified correct airflow when a thing is operating hot. And the correct procedure, according to IMAC, is to use that, what they used to call Tempelac, temperature indicating paint, and put it up here on top to verify that envelope isn't getting way too hot. I think I remember figures of like 215C or 260C. What I did here for temperature measurements was use this cheap but effective clamp multimeter with temperature and a bead welded type, probably iron Constantine thermocouple. So a little tricky to put in there, and of course would be rather dangerous to put in there with an operating tube. How to hold it in there against a tube is the problem. I put a piece of high temperature tape to hold it against the glass. If that's operating and that happens to pop up and hit that plate terminal, that could be very dangerous, so be extremely careful. But one could find a way to put a thermocouple up there and actually measure it. So that should be about all the tricks you need to get these tubes installed and set up for correct airflow. davecbyp did it. And a couple of end notes. The website with really good information on fans is Punker, punker.com. I assume that's Germany. And subdirectory fan technology, but Google that. Very good information. And by the way, I'm not the subject matter expert here. I verified all this with the XYL, who's a mechanical professional engineer in the nuclear world. who says she's not the world expert either, but between us we've ironed out these details, at least for this fairly simple setup. This question becomes extremely complicated because we're trying to model airflow, and that's horribly difficult. Air and fluid flow modeling is extremely difficult. But if you really want to deep dive this topic, you won't find this in the books, but the flow between that glass chimney and tube needs to be somewhat turbulent. There's two kinds of flow, turbulent versus laminar. Laminar means all the air. Why is my light flashing? Like Bobcat Goldthwait said, do I have a tumor or did it get dark in here? And if you've never seen Bobcat and you're reasonably tolerant morally, watch his comedy. He's crude, but he's very good. Not safe for work. But that flow needs to be somewhat turbulent. If it isn't, in theory, only the air that contacts the surfaces will transfer heat. Turbulence is kind of like putting we're in England and we put some milk in tea because it's uncivilized to have tea without milk. I forget what movie that was from. Oh, or it may have been the MASH or Hogan's Heroes. But we put some milk in a cup of hot beverage and it kind of lays there until we stir it a little bit. Similar thing. And there's going to be turbulence, and it's probably built in by the nature of these holes in this arrangement here. So if you want to do some more refined testing and improvements, you can change the turbulence, but that would be a bit difficult. So there it is for end notes.